Welcome to this predicted paper from On Maths. This paper represents the best guess for the upcoming exams. Please use this paper in addition to your other revision. You can complete a unique version of this paper by going to our On Maths site. On Maths is full of free content to help you prepare for your exams, such as topic-based papers, demon questions, and mini mocks. If you like what we do, please consider subscribing. Enjoy! So we need to first of all understand what a cube number is. So a cube number is the answer to when you get three integers or whole numbers and we multiply them by themselves three times. So 1 times 1 times 1 is 1, 2 times 2 times 2 is 8, 3 times 3 times 3 is 27, 4 times 4 times 4 is 64, and 5 times 5 times 5 is 125. So 1, 8, 27, 64, 125 are all cube numbers, and it goes on forever. And this question's asked us to find all the odd, or an odd, cube number that is smaller than 100. So it has to be odd, so that gets rid of the 8 and the 64. And it has to be smaller than 100, so that gets rid of the 125. So I can either write down 1 would be a fine answer, or 27. I'm going to go for 1. There are 10 squares in total, so each square is worth 1/10. And if we count all of the shaded squares, we notice that in total there are 7 shaded squares. So that's 7 lots of 1/10, or 7/10. So a prime number is a number that is only in the 1 times table and its own times table. So 4, for example, is not a prime number because it is also in the 2 times table. 6 is in the 2 times table. 15 is in the 3 times table. 21 is also in the 3 times table. 9 is also in the 3 times table. Now 1 is a bit of a special case. The definition is that it has to be in 1 and its own times table, and technically 1 is only in one of those, so 1 is not a prime number. The smallest prime number is actually 2, but 2 is not in this list. 23 though is not in any other times table, so 23 is a prime number. So with this question we need to first of all count how many sides this polygon has. So it's going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it's 10 sides. And we just need to know that a 10-sided shape is a decagon. Now we are expected to know all of the names of shapes between 3 and 10 sides. So if you don't know them already, just sit down and learn them. For us to create the smallest number, we need to pick the smallest digits at the start of the number. So the smallest digit is 3, then the next smallest digit is 4, next smallest digit is 5, then the next smallest digit is 8. But it wants it to be an odd number, and this is an even number. So we have to move that 8 forward 1 and have that 5 at the end. So the smallest odd number is 3,485. So we can draw out our place value grid to help us out with this question. We've got thousands, hundreds, tens and units. So we'll need another one there. So thousands go here, hundreds here, tens here, and then units here. So this says 2,000. So a 2 will go in the thousands column. 30, so that'll be a 3 there, and 2. So we need to fill in a 0 here to keep that 2 as 2,000, otherwise that would collapse and it would become 232. So the answer is 2032. And to work this out, we just need to type in 0.3 on the calculator and then press a button that mostly, on most calculators, looks like this, and it will just square it for us. If you can't find that button, all you need to do is do 0.3 times 0.3, and that will give you the same answer of 0.09. I'm going to start just by copying out the question. Now when we're asked to solve, it means we need to find x, okay? And I'm going to start by putting in my solving lines, which are just lines to the left and right of the equal sign. And what we need to do is get x on its own on the left hand side. Well, what's stopping x from being on its own? We've got this 12 here. Well, what's that 12 doing to the x? Well, it's timesing it by 12. So we need to do the opposite of that to get rid of it. What is the opposite of times 12? Divided by 12. Now these lines show us we've got to do the same to the left and right. So if I divide the left hand side by 12, I have to divide the right hand side by 12. So on the left hand side we just have the x, which is what we want. On the right hand side we do 36 divided by 12. How many 12s in 36? That would be 3. So our solution is x equals 3. So we're going to start by writing 5 over 9 as a decimal. And to do that we just need to do 5 divided by 9, which will be 0.5 recurring. And to convert between a decimal and a percentage, we just times by 100. So we're going to get that 0.5 recurring, and we're going to times it by 100, and that will equal 55.555 recurring. And to the nearest percent, that's going to be 56, because that 5 will move that 5 up by 1. If we write in how many sides each shape has, triangle has 3, quadrilateral 4, pentagon 5, hexagon 6, you'll notice the number of vertices is twice the amount of each of them. So if a shape has 15 sides, we just times that by 2 and it will have 30 vertices. In algebra, we don't show the times sign, so 17 times A times B just simply becomes 17AB. If we try to draw a quadrilateral with a pair of parallel sides, and then it's a quadrilateral, so join them up, it's got 4 sides, then the shape we draw will always be a trapezium. So our answer is that it is a trapezium. Now you might think that a rectangle and square does have one pair of parallel sides, but it actually has 2 pairs of parallel sides. The definition of a trapezium is it has just one pair of parallel sides, and any quadrilateral that has one pair of parallel sides is a trapezium. Let's rewrite this expression, but with a time sign in, so v times w squared. Now w squared just means times by itself, so we can rewrite that as v times w times w. Okay, so we know v is minus 10, so minus 10. And we know w is minus 4, so it's times minus 4 times minus 4. Okay, so when you multiply, it doesn't matter which order we do it. So what I'm going to do is I'm just going to do these ones first, and I'm going to ignore that times minus 4 at the end. So minus 10 times minus 4, that's a minus times a minus, which is a positive, 10 times 4, which is 40, times minus 4. Now we're going to do 40 times minus 4, so it's a positive times a negative, so that's going to be a negative. And 40 times 4, well, 4 times 4 is 16, so 40 times 4 is 160. So it's going to be minus 160. So we have an original amount, and this represents 100% of the original amount. The new price, new amount, represents 113% because it has said that it has gone up by 13%. So it has increased by 13%. And as a value, that increase is £1,287. So it's 13% of the original. It's gone up 13% of the original price. So what we're going to do is we're going to work out what 1% of the price increase is. Instead of 13%, we're going to work out what 1% is. And we're going to do that by dividing the amount by 13, and we get 99. So 1% represents £99. So 1% of the original represents £99. But the new amount is 113%. So we need to times the £99 by 113, which gives us £11,187. So the picture is now worth £11,187. To be able to work out the area of a circle, we first need to work out what the radius is. Now the radius is half the distance of the diameter. So if the diameter is 16 centimeters, the radius will be 16 divided by 2, which will be 8. So the radius is 8. The formula for working out the area of a circle is pi r squared, or pi times r squared. The radius is 8, so it's pi times 8 squared, or pi times 64. When we type that into the calculator, we get 201.061, blah blah blah. And the question asks it to 2 decimal places, so rounding that to 2 decimal places, we get 201.06 centimeters squared. All probabilities have to add up to 1. So what I'm going to do is I'm going to take away these probabilities away from 1. So we're going to do 1 take away 0.09 plus 0.13 plus 0.18. And so that's going to be 0.4. 1 take away 0.4 is 0.6. So our sequence, our nth term, is 20 times n plus 6. For the fifth term, n would be 5, so it's 20 times 5 plus 6. 20 times 5 is 100, 100 plus 6 is 106. So for this question, we need to understand that the units we currently have are in meters per second, and the units we want to get them to or convert them to are kilometers per hour. Now to convert the meters part is quite easy, because all we need to do is divide by 1,000. And when you divide the top of a fraction by 1,000, all you do is you just divide the whole thing by 1,000. So we're just going to divide the whole thing by 1,000. So we've got 95, and we're going to divide the whole thing by 1,000, so we get 0.095, and that's going to be kilometers per second, because we haven't dealt with the seconds yet. So that's the easy part. The more difficult part is converting the seconds to hours. So to convert seconds to hours, we divide by 60 and then divide by 60. So we divide it by 360. Seems simple enough. But the seconds are at the bottom of a fraction, and when you divide the bottom of a fraction by something, you actually times the whole fraction by that thing. So we're going to times the whole fraction by 360. And so we do 0.095 times 360, and you get the answer of 342 kilometers per hour. So our answer is 342 kilometers per hour. For this question, it's really useful to label angles that you know on the diagram, even if you can't go straight to the answer. So I know that if I extend this line here, but let's do a bit of a better job of that. So if I extend this line here, the north line, then I can work out what this angle is, because it's going to be the same as this angle here. And the reason is it's Z angles, which are alternate angles. So I know that this angle is 35 degrees because of alternate angles. The question asks to find the bearing of C from B. So we're at B and we're finding the angle that C makes from north going clockwise. Well, it's going to be this angle here we're looking for. And if we look, we already know what this side is, which is 180 degrees because it's a straight line. We've got the 35 degrees there, and we've got the 21 degrees. So it's going to be 180 plus 21 plus 35, it doesn't matter which order we add them, which will equal 236 degrees. The modal class is just the group that has the mode. Okay, the modal group. Class just means group. Now all these guys here are groups, so any of these could be the answer. To find the modal class or the modal group, we just look to see which one has the most numbers in it. Well, the first group has 16 in it, the next group has 11, the next group 17, the next group 11, and the next group, or the last group, 13. Which of those is the most? Well, 17. So the group that has the most is this 30. Let's do that a bit nicer. 30, and then C, and then 35. That essentially means 30 to 35, but make sure you copy it down correctly from the table, so exactly as it shows it in the table. To find the average rate of petrol usage, which I'm just going to call rate, what we're going to do is we're going to get the distance travelled by the car, and we're going to divide that by the amount of fuel used, so the volume of the fuel used. So the distance was 135 kilometres. The volume of the fuel used was 9 litres. We do 135 divided by 9, which is 15. So it's 15, and this was in kilometres, and this was in litres. So it's going to be 15 kilometres per litre. So for this question, we just need to pick one of the coordinates. And I'm just going to pick this one here. And we just need to work out what the coordinates are. Well, it's going up in 2, so it's going to be 4 on this side. And this is kind of 4.5, so that's going to be 19 there. So we know it's 19 at the bottom and 4 at the side here. So we're going to have a look on our table for a 4 and a 19. We've got a 19 and 23 here. It's got to be a 4 and a 19, which is here. And it shows that the 4 is for paper 1 and the 19 is for paper 2. So our answer will just be paper 2. We're going to start off by finding what the multiplier will be. So we'll start off with 100%, and it's a decrease of 32.6%. So we're going to take that away, and that will leave the percentage as 67.4%. Next we need to convert that into a decimal. So we're going to divide it by 100, and that will make it into a multiplier. And the beauty about a multiplier is all we need to do is get the amount from the question, 486, and times it by the multiplier, and it will do all the hard work for us, and it will give us the answer of 327.56. These types of angles aren't exclusive to parallel lines, but they do crop up quite a lot of times when you're dealing with parallel lines, and these are vertically opposite. So when you've got an angle this side and an angle this side of where two lines intersect, they're known to be vertically opposite. And the beautiful thing about vertically opposite angles is they are equal. So x is just going to equal 15 degrees. And the reason you need to state is that they are vertically opposite. Make sure you state vertically opposite. Sometimes in some exams opposite is enough, and in other exams it has to be vertically opposite. First of all, we're going to work out what angle BCA is. And the way of working this out is it's going to be the same as what BAC is, because the angles in an isosceles, the bottom two angles in an isosceles, when it's pointed up, are equal. So this is also going to be 15x. Make sure you state the reason. So it's an isosceles triangle. Okay, so if this is also 15x, we know that angles BAC plus ACB plus ABC, so basically all three of the angles in the triangle, are going to add up to 180. So 15x plus 15x plus 30x is going to equal 180, because it's angles in a triangle. Get my lines in, my tram lines in. 15x plus 15x plus 30x, well 15 plus 15 is 30, 30 plus 30 is 60, so it's going to be 60x equals 180. Then we're going to divide both sides by 60, and we have x equals 3. So the answer will be 3. I'm going to start by just labelling the missing angles on each of the triangles. So we've got a missing angle here, which is 40, because we're going to take away 105 and 35 from 180. And we've got a missing angle here, which is 35 degrees. Again, taking away 105 and 40 from 180. So the tempting answer is to say that G is 2 meters, because they're both at the bottom of the shape. But have a look at where 2 meters is, and have a look at where G is. G is between 35 degrees and 105 degrees. It's the length between those two angles. Well, the 2 meters is between the 105 degrees, but the 2 meters is between the 40 degrees and the 105 degrees. So if we look at this left-hand triangle and see where the 35 degrees is, it's up here. So actually the corresponding lengths are this one and this one. And because they're congruent triangles, we know that the lengths are going to be the same. The difficulty with finding the perimeter of this shape is we do have some of the lengths missing. So we're going to find the lengths that are missing first, and then we'll find the perimeter. So the one on the right here is going to be the same as the one on the left. So this is going to be 5.6. Same with the one on the left of the 2.4. So this will be 2.4 here. This length here is going to be slightly more tricky to work out. What we do is we work out the total length across, or the total width across, which is 9.8, and we take away the bits that we know. So we take away these purple lengths at the bottom. So to work out the length of the missing bit, we're going to do 9.8, and we're going to take away the 4.3 plus the 1.2. And then when we do that, we do 9.8, take away those bits, we get 4.3. So this missing bit here is 4.3. So to work out the perimeter, we're going to start at the top left of the shape and add up all the lengths as we go around the shape. So 9.8 plus 5.6 plus 1.2 plus 2.4 plus 4.3 plus 2.4 plus 4.3 plus 5.6. When you add all those up together, you get 35.6. It's a perimeter, which is a distance, so our units are centimeters. So trying to describe the single transformation, it kind of looks like it could be a rotation, and it would be a rotation of 180 degrees. But if it was a rotation, it would be actually this way around. And so it's not a rotation. It looks to me like it's a reflection, which it is. Now we've got to find out where we put our mirror line. And our mirror line for this would be a horizontal line. So if I just guess and I put it down here, notice that B is only one jump away from that, and yet A is 1, 2, 3 jumps away from that. So that's not very good. That's not the halfway point. So we need this to be the halfway between the two shapes, which is going to be here. And the name of that line, well, everywhere along that line, y is equal to -1. So we call it the y equals -1 line. So it's going to be a reflection across line y equals -1. So we're asked to rotate the triangle A 90 degrees clockwise and the centre of rotation at 0, 0. So we're going to first of all just show where the centre of rotation is, which is at our origin. And what you do is you get tracing paper, trace out the triangle, and rest your pen or pencil at 0, 0. So I'm just going to draw it out. So just copy it out. And what you do is you'd push your pen into 0, 0. And unfortunately I can't do that. But when you rotate it 90 degrees clockwise, the shape will end up here. And so we just got to line this up perfectly. A little bit less rotation maybe. There we go. And then what you do is you'd lift your tracing paper and just draw in the shape underneath. And it says to label in the triangle as B. So we're just going to substitute the values that were given into the formula. So v squared equals, and then u is 16.4 squared plus 2 times a, which is 0.2, times s, which is 110.2. Type that into the calculator and you get 313.039 blah blah blah. And what we're going to do is we're just going to quickly solve this by square rooting both sides, because it's v squared equals and we just want v equals. So v equals, and we're just going to square root that on the calculator, 17.692 blah blah blah. It says it wants it to 2 decimal places, so that's just going to be 17.69. Integer just means whole number, so we're looking for all the whole numbers that satisfy these two inequalities. Well, the first inequality says that it has to be greater than 3. So the smallest number that is greater than 3 is 4. The second inequality says it has to be less than or equal to 8. So I'm just going to keep going till I get to a number that is less than or equal to 8. It can't be 9 because 9 is not less than or equal to 8. So our answer is 4, 5, 6, 7 and 8. To draw a quadratic graph, we want to find as many values as we can. Because it's a curve, with a straight line graph you only need 3 points. With a curve you need as many as you can get. And now we're actually given a table here to fill out. And so I'm going to start off with a 0 here. And here we want to substitute in the x equals 0 into our equation. So we've got y equals x squared plus 11. So it's y equals 0 squared plus 11. 0 squared is just 0, plus 11 is going to be 11. We're going to do the same for 1. So y equals 1 squared plus 11. 1 squared is just 1. 1 plus 11 is 12. Same again for 2. 2 squared plus 11. 2 squared is 4. 4 plus 11 is 15. Now the minuses are a little bit more difficult, but not that much difficult, because when you square a negative you actually get a positive. So minus 1 squared is just 1. 1 plus 11 is 12. And then minus 2 squared plus 11. Minus 2 squared is 4. 4 plus 11 is just 15. Now you can see here we get a nice little symmetry. And we're going to plot this onto our graph here. So 11 is going to be here. 12 is going to be here. So both of these are 12. And 15 is going to be here. Now when you join them up, what you want to do is avoid having a V. Okay, in the mark scheme specifically it says that the bottom needs to be nice and smooth, and avoid something called feathering where it looks like that. You just want one smooth line. Now the best way I find of doing it is turn the page sideways, which I can't do with mine, but you can turn your page sideways and just one smooth line, and we're going to do a nice smooth bottom there. And I just need to lift, try not to lift with yours, and that should be good enough for full marks. Let's just try it again, just have a bit more of a lift like that. That's also good, and I can do this all day. Like the ones that are bad are the ones with gaps, or the ones where they miss points. So if you had yours like this where it just missed that point out, or something like that, that would not give you the mark. You just want one nice smooth, just slip there a little bit, nice smooth, and that probably wouldn't, because you can see that I've kind of hesitated there. So it just takes practice, and as I said, if you turn the page sideways, it's a lot easier to draw a C than a U. First thing to do with this question is realise what information we have from the question. So it says that the toy car accelerates at that amount. So acceleration is an A. So its A is going to be 7 meters per second squared. And it says for 14 seconds, so that's a time. So the time is 14 seconds. It seems like there's no more information, but there is, because u is the initial velocity and it says from rest. So u is going to be 0. And it's asking us to find the displacement, so the s. And displacement is just a distance with a direction, so it's a vector distance. So we're going to have to look and see which of the formulae that we're given, so which of the 3 formulae we're going to use. So notice we don't have a v, so we're not using that top one, we're not using that bottom one, so we're going to be using that middle one. So we write the formula out, s equals ut plus half at squared. Now we're looking for s, so let's leave the s there. U is 0, so it's going to be 0 times 14 plus half times the a, which is 7, times the 14 squared. Put that into a calculator and you get 686. So the displacement is going to be 686 meters. So 7 times 10 to the power 4 is going to be 7, and it's going to be 70,000. And 9 times 10 to the power of 7 will be 90 million. And so when you add them together, you get 900700000. Now if you have access to a calculator, if this is on the calculator paper, then you can just type it into your calculator. Some people think there's a quick way of doing this, like adding the 7 and the 9. There isn't. You've just got to work out what this number is, work out what this number is, and add them together. There's a lot going on with this question, so I'm going to start off just having a look at the total amount of money. So I'm going to do this in pence, so 2115 pence. And if each merit point is worth 3 pence, then we can work out the amount of merit points by doing 2,115 divided by 3. So that gives us 705. So there's 705 merit points. Next, have a look at the question here, this part here, where it says James has X merit points. Sarah has 4 times as many points as James, so she's going to have 4x. Robert has 69 fewer merit points than James, so he's going to have x minus 69. And we know that that equals 705 because we've just worked that out. And this feels like a solving coming on. So we've got x plus 4x plus x, which is 6x. Minus 69 equals 705. And we're going to add 69 to both sides. So we've got 6x equals 774. Then we're going to divide 6 both sides. And so we've got x equals 129. So x equals 129. That means James has 129. Sarah has 4 times more, so she will have 516. And Robert has 69 fewer, so we're going to take 69 away from that, and that will equal 60. Factorising is the opposite of expanding, so instead of multiplying something out of a bracket, we're putting it in a bracket. I'm going to start just by putting the bracket down. And we're going to ask ourselves, what number can we divide out of 18 and 33? And we need the biggest number we can divide out of both of them. So we're essentially looking for its highest common factor. So 18 and 33, that would be 3. And there's no letter we can divide out of both of them because 33 doesn't have a letter. Next we ask ourselves, 3 times what is 18x? Well, 3 times 6 is 18. 3 times 6x will be 18x. Then we ask ourselves, what times 3 is 33? And that's obviously going to be 11. And you can expand that. 3 times 6x is 18x. 3 times 11 is 33. So we know we've got the right answer. So our answer is 3 brackets 6x plus 11. So we've got a right angle triangle and we're given 2 lengths and we're asked to find a third length, and that means we're going to be using Pythagoras' theorem. And to do that, we're just going to label the sides A, B and C, and C must be the hypotenuse, which is opposite the right angle. Pythagoras' theorem says that A squared plus B squared equals C squared. A we can see is 3.4, B is 5.2. And we're looking for what C squared is. So 3.4 squared plus 5.2 squared is 38.6. And we need to solve to find out what C is. And to do that, what we do is we just square root both sides. So square root of 38.6 is 6.212 blah blah blah. And C squared, the square root of that is C. So it's 2 decimal places, it's going to be 6.21. To find the force, we need the pressure and the area. We're given the pressure in the question, so all we need to do is find out what the area of this circle is. And the formula is pi times r squared, which will be pi times the radius, which is 5 squared, which will be 78.539 blah blah blah. The formula for pressure is pressure equals force divided by the area, and we rearrange that to force equals pressure times area. Pressure, it says, is 0.1512. The area we found out in the previous question, and we keep that in our calculator, so we keep the accuracy up, and when you do that you get 11.875 blah blah blah, rounded to the 2 decimal places it asks for, and you get 11.88 newtons. So if we imagine we've got the 25 meter pipe here, and we've got the 35 meter pipe here, the question's basically asking us what can we cut all these pipes into, and they all have to be the same length that will fit with the 25 meter and the 35 meter. And essentially what this question is asking is, what is the highest common factor of 25 and 35? So to find the highest common factor, what we do is we just find the factors of 25, which is 1 and 25 and 5 and 5, and the factors of 35, which will be 1 and 35 and 5 and 7. And the highest common factor is the number in both lists, the highest number in both lists, so it's 5. So what we can do is we can cut all of these pipes into 5 meter pipes. So 1, 2, 3, 4, not to scale, and then 7 of these, so 1, 2, 4, 5, 6. And so there's 7 in total. So each of these are 5 meter long, and there's no wastage. And that's the longest we can make the pipes for there to be no wastage at all. So my answer is 5 meters. I'm going to write this out just a bit bigger so we can see what's going on. And there are loads of different methods for expanding brackets. I'm going to use smile and rainbows. So smile there, rainbow there, and I always put a little notch here to remind me to times it. So we're going to do 4 times 8, which is 32, and x times x, which is x squared. Then we're going to do 4 times 3, which is 12, and x is just there. So when we expand that, we get 32x squared plus 12x. So this question says that Adrian, Ben and Charlie have some sweets, and the ratio of Adrian to Ben to Charlie is 9 to 6 to 13. But it also says that Charlie got 56 more sweets than Adrian. So there's 56 more sweets. Well, looking at the actual parts of the ratio, there are 4 more parts. So plus 4 parts, which represent plus 56 sweets. So the 4 extra parts are worth 56 sweets. So 4 parts are worth 56 sweets. So 1 part would be 56 divided by 4, which is 14 sweets. So all we need to do now is work out how many parts there are. Well, there are 9 plus 6 plus 13 parts, which is 28. And each part is worth 14 sweets. So the total number of sweets will be 28 times 14. So 28 times 14 is 392. So the only way of answering this question is to work out what these are as ordinary numbers. And so 7 times 10 to the power of 7 would be 7, 1, 2, 3, 4, 5, 6, 7. And 9 times 10 to the power of 4 would be 90,000. So that would be 9, 0, 0, 0, 0. And so we're just subtracting them like that. And so we'll get 6, 9, 9, 1, 0, 0, 0, 0. And obviously if this is on the calculator paper, just type it into your calculator. There are no tricks here. You can't do anything with the 7 and the 9. You're not subtracting powers or anything. You're just literally typing in what it says. And there's a button on the calculator like that you will need to use. So if you don't know what that is, ask your teacher or ask someone to help you out with that. So we're going to start just by writing this out. So m equals 7 brackets x minus 10. And we're going to put our solving lines in. I'm going to start by expanding the brackets. And we don't need to. We could divide both sides by 7, but I think this is a bit easier. And we're going to subtract, or we're going to add 70 to both sides. So we're trying to get x as the subject. So we're trying to get x on its own. And we're next going to divide both sides by 7. So we have m plus 70, all of that over 7 equals x. So x equals m plus 70 over 7. So the formula we need here is that the sum of the interior angles is equal to the amount of sides, take away 2 times 180. So we know that the sum of the interior angles is 2160, and we're looking for what n is. So we're going to do a bit of solving. Not too difficult. We're going to divide by 180 both sides, and that will give us 12, and then we're going to add 2 both sides, and that would be 14. So the amount of sides is 14. Any number to the power of 0 is equal to 1. So it doesn't matter if it's a number or a letter, it's always going to equal to 1. When something is cubed, you times it by itself 3 times, so we're going to do the same here. So we've got 5x to the power of minus 6 times 5x to the power of minus 6 times 5x to the power of 6. We're going to put the 5's together, so 5 times 5 times 5, and the x to the power of minus 6's together. 5 times 5 times 5 is 125. Now when you times powers with the same base, which we have here because they're all x to the power of minus 6, you add the powers together. So minus 6 plus minus 6 plus minus 6, which is going to be minus 18. Something else we could have done is we could have done 5 to the power of the 3 here, 125, and then done minus 6 times the 3, which would have given us minus 18. When you have a number next to a letter, it's the same as putting a times there, so we're just going to write this out, but by putting times symbols in. Put the numbers together and the x's together. So here we've got 3 times 7, which is 21, and x to the power of 5 times x to the power of 4. Whenever you multiply bases with powers, you just add the powers as long as the bases are the same. So they're both x to the power of something, so we're just going to add the powers together. 5 plus 4 is 9. If we try and visualize this question on a graph, then we've got C, which is somewhere here. So we've got C, which is somewhere here at coordinates 2, minus 12. And we've got D, which is somewhere here at coordinates 8, 4. And we're asked for the length of the line segment. So we're asked for this distance here. Now we can see that we can actually make a right angled triangle with this line segment. And we've got to find out what each of the sides is going to be. So the bottom one starts at x coordinate 2 and D it goes to x coordinate 8. So it's going to be 8 take away 2, which is going to be 6. So the distance there is 6. And how far does it go up? Well, we've gone from minus 12 to 4, so that's gone up 16. And we know that when we've got a right angled triangle, which this one is, and we're asked for one of the lengths, having given the other 2, we're going to be using Pythagoras. So for Pythagoras, label the sides A, B and C, with C being the one opposite the right angle. And we write down the Pythagoras' theorem, which is a squared plus b squared equals c squared. A squared, we've said, is 6, b is 16, and 6 squared plus 16 squared is going to be 292. And then we're just going to quickly solve this by square rooting both sides. And so we're left with 17.088 blah 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 is equal to C. And because it asks it to 2 decimal places, we're going to write the answer of 17.09. The formula for an exterior angle for a regular polygon is 360 divided by the amount of sides. Now here we're given the fact that the exterior angle is 30 and we're looking for n, so we just need to rearrange the equation. We can times both sides by n. And then divide both sides by 30. And so we've got n equals 360 divided by 30. And when you do 360 divided by 30, we get the answer of 12. So it's a 12-sided shape. So here we're asked to factorise a quadratic, and our answer will be x plus or minus something, x plus or minus something. So it'll be 2 sets of brackets with an x at the start. Okay, so to be able to find out what's in the bracket, we look at the 36 there, and we know that we're going to have to multiply 2 numbers together to make that 36. And we look at the coefficient of the x, that 15, and we know we're going to have to add these numbers together to make that 15. Now, if you just can figure out in your head the answer, that's absolutely fine. If not, you can just quickly write down the factors of 36. Now, because they multiply together to make a positive 36, they'll either both be positive or both be negative, but they add together to make a positive number. So we're just looking at the positive factors. So 1 and 36, 2 and 18, 3 and 12, 4 and 9, and 6 and 6. And we're looking for which ones of those add together to make 15. And we can see here it's going to be 3 and 12 add together to make 15. So our 2 numbers are going to be plus 3 and plus 12, or the other way around. So the way this formula works is we have m, which is the final amount. The 2000 here is our initial amount. The decimal in here is our multiplier, and the power here is the amount of years. So the way multipliers work is they are the percentage divided by 100. So if we go the other way and times it by 100 to make it back into a percentage, it will be 102.9%. Now it says, what is the interest rate of the bank? Well, the interest rate is always going to be 100%. Well, this 102.9% is 100% plus the interest rate, which will equal the 102.9%. So the interest rate is going to be the 2.9%. You always start off with 100%. So if I put £5 into my bank, I've got 100% of that £5, and then the interest rate is on top of that 100%. So our answer here will be 2.9%. There are a couple of different methods for drawing a graph, and we're going to do the cover-up method. So I'm going to start just by writing out the equation. And what I'm going to do is I'm just going to completely cover up, and I'm going to do this with a little highlighter maybe. I'm going to cover up the minus 3y. I'm just going to cover up the y term. And so what that leaves me with is 10x equals minus 30. So if I get my solving lines in, I just need to divide by 10 both sides. So we've got x equals minus 30 divided by 10 is going to be minus 3. Now x equals minus 3 gives us the x-intercept. So we know that the x-intercept is minus 3. What is the x-intercept? Well, it's where the graph will hit the x-axis. So it'll hit it at minus 3. I'm going to do the same thing again. But this time I'm going to cover up the x term. I'm just going to cover this up. And so we're going to end up with minus 3y equals minus 30. Again, put my lines in. And this time I'm going to have to divide both sides by minus 3. And so we've got a minus divided by minus, which is a positive. 30 divided by 3 is 10. So our y-intercept will be 10. Y equals 10. So that will be here. And we know that the minimum amount of points we need to be able to draw a graph accurately, well, to draw a graph are 2. So if we've got 2 points, we can draw a graph. And here we do have 2 points. So I'm just going to draw in this graph as best as I can. And make sure your graph goes for the complete graph. Then make sure your line continues on for the complete graph, and don't just draw it between the x and the y-intercepts. So when we're doing column vectors and adding and subtracting them, we just literally add and subtract the top and bottom numbers. So a plus b minus c will be, just looking at the top, 9 plus 18 minus 9, 9 plus 18 minus 9, which will equal 18. And the bottom will be 9 plus minus 18, so really minus 18, and minus 9, and so that will be minus 18. So our column vector will become 18 minus 18. So we're asked to go from B to D. So we're starting at B and going to D. Now we've got a problem here. With B, there are no roads out that we know the name of. We don't know the name of this. We don't know the name of that. Well, actually we do. Two vectors that have the same direction and the same length are the same. So this length here is also going to be P, or the vector is also going to be P. So to get from B to D, we're going to go down this road and then down this road. So the first road was P. Second road, we're going backwards down Q. So it would be minus Q. Now for those of you wondering, if we go down this road and this road, it will give us the same vector, because this road here is Q that way. So minus Q plus P is exactly the same. So to find the probability of A and B, which is what that sign means, we're going to work out the amount of people, or the amount in A and B, and we're going to put that over the total amount. So A and B means it's the overlap, so that's going to be 7, and the total amount is all of the numbers added together, which will be 23. So our answer is that the probability of picking A and B is 7 over 23. So in this question we've got a right angle triangle and it involves two lengths and an angle, so it's going to be a trigonometry question. So we're going to start by labelling the sides. So we've got the hypotenuse opposite the right angle, opposite is opposite the marked angle, and the adjacent is between the right angle and the marked angle. Now notice the opposite doesn't have a number or a letter next to it, so we're going to cross that out, we're not interested in that. We're next going to draw our triangles for SOHCAHTOA. So it'd be SOHCAHTOA. And we cross out the opposite, so we're not looking at a sine or tan, we're going to be looking at the cos. So it would be cos the angle, or cos x, equals A over h. And the angle is 37, so cos 37 equals 7.1 over x. Now, whenever you're in this situation, and we're just going to put our solving lines in because we're going to be solving this next, if I can press the right button, there we go. And whenever you're in this situation, what you can do is swap the left-hand side, it has to be the whole of the left-hand side, with the x at the bottom. You can just swap those over. And effectively what we're doing is multiplying both sides by x and then dividing both sides by cos 37. So when we swap those over, we get x equals 7.1 over cos 37. When you type that into your calculator, just make sure you close the bracket. If when you type in cos it opens a bracket, make sure you close the bracket before you ask your calculator for the answer, or press the equals button, and that would be 8.890 blah blah blah. And when you round that to two decimal places, it will be 8.89. So what's happened here is that the company's increased the amount of sweets by 15%. So we're just going to focus on that and work out what the multiplier would be first. So they started off with 100%, and they added 15%, and then therefore they ended up with 115%. And to find that as a multiplier, we get the 115 and divide it by 100, and that gives us 1.15. So that is the multiplier they used. Now they used that multiplier on the original amount, and they times it by 1.15, and they got the answer of 69. But if we're working the other way to find out what they times by 1.15, we get that 69 and we divide it by the multiplier. So if we want to work out what the original number was, we divide it by the multiplier, and that gives us 60. So the answer will be 60. The surface area of a sphere is found with the formula 4 pi r squared, with r being the radius of the sphere. So we're going to do 4 times pi times the 20, and that gives us 5026.548 blah blah blah. And when we round that to two decimal places, we get 5026.55 centimeters squared. To find the volume of a cone, we use a simple formula, which is 1/3 times pi times r squared times h. The r is the radius, so that's the 5 squared, times, and h is the perpendicular height, the one at right angles, so that is 10. When you work that out on a calculator, you get 261.799 blah blah blah. And when we round that to two decimal places, we get 261.80. With this question, you've just got to know what the different functions look like. So with C and D, we've got quadratic functions. One's a positive quadratic, which is a U shape. One's a negative quadratic, which is a kind of upside down U shape or an N shape. And here we don't have that, so we can get rid of those in our thoughts straight away. A is a positive cubic, which goes up, then down, then up again. And B is a negative cubic, which goes down, up, and then down again. So this one here goes up, down, up again. That's going to be a positive cubic. So our answer is A. I'm going to first of all draw the two triangles out separately. And we've got A, B, C, and then A, D, E. And the first thing to notice is we have similar triangles here, and the way we know that is that we've got an F angle here, which means they're corresponding on the two parallel sides, so these two angles are the same. We've got exactly the same thing on this side, we've got F angles, so these two are corresponding, and then the top angle is shared between the two triangles. And when you've got two triangles with exactly the same angles, they are going to be similar, which means one's an enlargement of the other. I'm just going to put on the length that we've got. Now we're looking for quite a complicated one. We're looking for the length CE, which is this one here. Now I can't actually label that onto my two triangles, but what I do know is that CE is equal to AE minus AC. Now we know what AE is, which is 60. So we just need to find out what AC is, this one here. And when we find out what AC is, we can just take them away to work out what the CE is. So we need two corresponding lengths that we know both of them. So we've got the 9 and 36 here. Because these two triangles are similar, we know that we can work out what the scale factor is. And to work out the scale factor, you do big divided by small. So 36 divided by 9. And we work out that that is going to be 4. So we know we're going to have a scale factor of 4. So to get from the smaller triangle to the big one, we times it by 4. But here we have the one, we need to find out what this one is. So one corresponding is this one. We're going from the big to the small. And so to work out from the big to the small, we've got to divide it by the scale factor. So divide it by 4. So 60 divided by 4 is 15. So we know what this one is. So AC is 15. And so we're going to do AE, which is 60. Take away the 15, and that will tell us what CE is, which is 45. So our answer is 45. So we're going to start off with 100%. And it says that the card depreciates. That means goes down by, so it goes down by 1.7% every year. So we do 100, take away 1.7, which is 98.3. And that's percent. And we want that as a decimal, or as a multiplier we call it. And so we just divide it by 100 to make it into a decimal, 0.983. And that's our multiplier. And the beautiful thing about a multiplier is we just need the amount of years. Well, it says from 1980 to 1985. So that's going to be 5 years. So it's going to be 5 years. And so what we do is we get the original amount, which was 2,245, and times it by the multiplier 5 times. Now I can't be bothered on my calculator to times it by 0.983 5 times. So what you can do is you can do it to the power of 5, which basically means the same thing. And that gives us 2060.553. And when we round that, that would be £2,060 and 55 pence. We're going to start by drawing a table of values. We draw the table of values because we've got a curve here, and with a curve you need quite a lot of coordinates to make sure you get the curve right. Now ideally I'd go up in halves, but so that I'm not just sitting here writing numbers, I'm going to go up in ones on this one. I'm going to leave a space there though, and we'll see why in a second. So what I'm going to do is type these into a calculator. I'm going to type in 0.5 times brackets minus 2 close brackets cubed plus 8 into the calculator, and that gives me the answer of 4. I do the same with minus 1, that gives me 7.5. 0 gives me 8. 1 gives me 8.5. 2 will give me 12. 3 will give me 21.5. The reason I've left a space there is this axis doesn't go up to 21.5. So what I'm going to do is just do 2.5 to see if it goes up to that, and that should be 15.8125. So that's actually quite useful because that shows that it's not quite 16. So we were aiming for roughly where 16 is. So next thing we do is plot these coordinates. So 2 would be at 4, minus 1 is 7.5, which we can't be perfectly accurate for, but it's roughly there. Then 0 is 8. Then 1 is 8.5, roughly there. 2 is 12. And then 2.5 is just below that 16. So it's almost at 16. Then the next thing we do is just join it up with a nice smooth curve. It's sometimes helpful if you turn your paper sideways. Obviously I can't do it when I'm on this computer. But you want to just keep drawing and don't lift your pen off at all. Just go with the points. And you want to avoid things like feathering, which is like that, where you do that kind of thing. And you kind of want to avoid, or you want to make sure you go through the coordinates. And you just make it a nice smooth curve. The exam is very forgiving when it comes to curves. They know that not everyone's got the steadiest of hands. So as long as yours goes through the points and doesn't have like gaps in it or feathering or anything like that, and it's just one continuous smooth line, then you'll get the marks. To find the perimeter of this sector, we've got to first of all find out the length of the arc, which will be this part here. And the formula for arc length is, first of all, we find out the fraction of the circle we have. So we put the angle over 360, and that will tell us the fraction of the circle that the sector is. And then all we do is we times that by the circumference, which is pi d. And so that's going to be 49 over 360 times pi times, and the diameter would be twice the radius. The radius is 7, so it would be times 14. When we do all of that, we get 5.986, blah, blah, blah. But that is not the perimeter yet. Perimeter needs to include, get the right ones, needs to include these parts here. So the perimeter will be the 5.986 plus a radius plus another radius. And when we do that, we get 19.986, blah, blah, blah. And we want to round it to 2 decimal places, so that will be 19.99 centimetres. You can complete a unique version of this paper by going to our OnMaths site. OnMaths is full of free content to help you prepare for your exams, such as topic-based papers, demon questions, and mini mocks. If you like what we do, please consider subscribing.